Sir Chandrasekhara Venkata Raman, FRS, was an Indian physicist, born in the former Madras Province, whose groundbreaking work in the field of light scattering earned him the 1930 Nobel Prize for Physics. He discovered that, when light traverses a transparent material, some of the deflected light changes in wavelength. This phenomenon is now called Raman scattering and is the result of the Raman effect. In 1954, he was honoured with the highest civilian award in India, the Bharat Ratna. Early years. Raman was born to a Tamil Brahmaniya family in Tiruvannaikaval, Trichinopoly, Madras Presidency, Tamil Nadu, in British India to Parvati Amma. Family. Raman's father initially taught in a school in Tiruvannaikaval, became a lecturer of mathematics and physics in Mrs. A.V. Narasimha Rao College, Vishakhapatnam in the Indian state of Andhra Pradesh, and later joined Presidency College in Madras. Early education. At an early age, Raman moved to the city of Visakhapatnam and studied at St. Aloysius Anglo-Indian High School. Raman passed his matriculation examination at the age of 11 and he passed his FA examination with a scholarship at the age of 13. In 1902, Raman joined Presidency College in Madras where his father was a lecturer in mathematics and physics. In 1904 he passed his Bachelor of Arts examination. He stood first and won the gold medal in physics. In 1907 he gained his Master of Arts degree with the highest distinctions. Career. In 1917, Raman resigned from his government service after he was appointed the first Pallet Professor of Physics at the University of Calcutta. At the same time, he continued doing research at the Indian Association for the Cultivation of Science, Calcutta, where he became the honorary secretary. Raman used to refer to this period as the golden era of his career. Many students gathered around him at the IACS and the University of Calcutta. On 28 February 1928, Raman led experiments at the IACS with collaborators, including K.S. Krishnan, on the scattering of light, when he discovered what now is called the Raman effect. A detailed account of this period is reported in the biography by G. Venkataraman. It was instantly clear that this discovery was of huge value. It gave further proof of the quantum nature of light. Raman had a complicated professional relationship with K.S. Krishnan, who surprisingly did not share the award, but is mentioned prominently even in the Nobel lecture. Raman spectroscopy came to be based on this phenomenon, and Ernest Rutherford referred to it in his presidential address to the Royal Society in 1929. Raman was president of the 16th session of the Indian Science Congress in 1929. He was conferred a knighthood, and medals and honorary doctorates by various universities. Raman was confident of winning the Nobel Prize in Physics as well, but was disappointed when the Nobel Prize went to Owen Richardson in 1928 and to Louis de Broglie in 1929. He was so confident of winning the prize in 1930 that he booked tickets in July, even though the awards were to be announced in November, and would scan each day's newspaper for announcement of the prize, tossing it away if it did not carry the news. He did eventually win the 1913 Nobel Prize in Physics, for his work on the scattering of light and for the discovery of the Raman effect. He was the first Asian and first non-white to receive any Nobel Prize in the sciences. Before him, Rabindranath Tagore had received the Nobel Prize for Literature in 1913. Raman and Surabhagavantam discovered the quantum photon spin in 1932, which further confirmed the quantum nature of light. Raman had association with the Banaras Hindu University in Varanasi. He attended the foundation ceremony of BHU and delivered lectures on mathematics and some new paths in physics during the lecture series organized at BHU from February 5 to 8, 1916. He also held the position of permanent visiting professor at BHU. During his tenure at IISc, he recruited the talented electrical engineering student N. Ramachandran, who later went on to become a distinguished X-ray crystallographer. Raman also worked on the acoustics of musical instruments. He worked out the theory of transverse vibration of bowed strings, on the basis of superposition velocities. He was also the first to investigate the harmonic nature of the sound of the Indian drums such as the tabla and the mridangam. He was also interested in the properties of other musical instruments based on force vibrations such as the violin. He also investigated the propagation of sound in whispering galleries. Raman's work on acoustics was an important prelude, both experimentally and conceptually, to his later work on optics and quantum mechanics. Raman and his student, Nagendra Nath, provided the correct theoretical explanation for the acousto-optic effect, in a series of articles resulting in the celebrated Raman-Nath theory. Modulators and switching systems based on this effect have enabled optical communication components based on laser systems. Raman was succeeded by Debendra Mohan Bose as the Palette Professor in 1932. In 1933, Raman left IACS to join Indian Institute of Science in Bangalore as its first Indian director. Other investigations carried out by Raman were experimental and theoretical studies on the diffraction of light by acoustic waves of ultrasonic and hypersonic frequencies, and those on the effects produced by X-rays on infrared vibrations in crystals exposed to ordinary light. He also started the company called Travancore Chemical and Manufacturing Co., Limited, which manufactured potassium chlorate for the match industry in 1943 along with Dr. Krishna Murthy. The company subsequently established 4 factories in southern India. In 1947, he was appointed as the first national professor by the new government of independent India. In 1948, Raman, through studying the spectroscopic behavior of crystals, approached in a new manner fundamental problems of crystal dynamics. He dealt with the structure and properties of diamond, the structure and optical behavior of numerous iridescent substances. Among his other interests were the optics of colloids, electrical and magnetic anisotropy, and the physiology of human vision. Raman retired from the Indian Institute of Science in 1948 and established the Raman Research Institute in Bangalore, Karnataka, a year later. He served as its director and remained active there until his death in 1970, in Bangalore, at the age of 82. Personal life. He was married on 6 May 1907 to Lokasundari Amal. They had 2 sons, Chandrasekhara and radio astronomer Radha Krishnan. Raman was the paternal uncle of Subramanian Chandrasekhar, who later won the Nobel Prize in Physics for his discovery of the Chandrasekhar limit in 1931 and for his subsequent work on the nuclear reactions necessary for stellar evolution. Achievements. During a voyage to Europe in 1921, Raman noticed the blue color of glaciers and the Mediterranean Sea. He was motivated to discover the reason for the blue color. Raman carried out experiments regarding the scattering of light by water and transparent blocks of ice which explained the phenomenon. There is an event that served as the inspiration of the Raman effect. On a December evening in 1927, Raman's student K.S. Krishnan gave him the news that Professor Compton had won the Nobel Prize for his studies of the scattering of X-rays. This led Raman to theorize that if the Compton effect is applicable for X-rays, then it may be for light also, and to devise some experiments. Raman employed monochromatic light from a mercury arc lamp which penetrated transparent material and was allowed to fall on a spectrograph to record its spectrum. He detected lines in the spectrum which he later called Raman lines. He presented his theory at a meeting of scientists in Bangalore on 16 March 1928, and won the Nobel Prize in Physics in 1930. Books. For compact work, see Scientific Papers of C. V. Raman. Rameshan. Volume 1. Scattering of Light. Volume 2. Acoustics. Volume 3. Optics. Volume 4 Optics of Minerals and Diamond, Volume 5 Physics of Crystals, Volume 6 Floral Colors and Visual Perception. Honors and Awards. Raman was honored with a large number of honorary doctorates and memberships of scientific societies. Knight Bachelor, Nobel Prize in Physics, Bharat Ratna, highest civilian award of the Republic of India, Lenin Peace Prize, Fellow of the Royal Society. He was elected a Fellow of the Royal Society early in his career and knighted in 1929. In 1930 he won the Nobel Prize in Physics. In 1941 he was awarded the Franklin Medal. In 1954 he was awarded the Bharat Ratna. He was awarded the Lenin Peace Prize in 1957. In 1998, the American Chemical Society and Indian Association for the Cultivation of Science recognized Raman's discovery as an international historic chemical landmark. India celebrates National Science Day on the 28th of February of every year to commemorate the discovery of the Raman effect in 1928. Archive of Raman research papers. The Raman Research Institute, founded by Raman after his tenure at IISc, curates a collection of Raman's research papers and articles on the web. Death. At the end of October 1970, he collapsed in his laboratory, the valves of his heart having given way. He was moved to hospital and the doctors gave him 4 hours to live. He survived and after a few days refused to stay in the hospital as he preferred to die in the gardens of his institute surrounded by his flowers. 2 days before Raman died, he told one of his former students, "Do not allow the journals of the Academy to die, for they are the sensitive indicators of the quality of science being done in the country and whether science is taking root in it or not." That same evening, Raman met with the board of management of his institute, and discussed with them any proceedings with regards to the institute's management. Raman died from natural causes early next morning on the 21st of November 1970. Posthumous recognition and contemporary references. On the 7th of November 2013, a Google Doodle honored Raman on the 125th anniversary of his birthday. A road in India's capital, New Delhi, is named C.V. Raman Marg. An area in eastern Bangalore is called C.V. Raman Nagar. The road running north of the National Seminar Complex in Bangalore is named C.V. Raman Road. A building at the Indian Institute of Science in Bangalore is named the Raman Building. A hospital in eastern Bangalore on ATFD Road is named the C.V. Raman Hospital. In Star Trek: The Next Generation, there is a United Federation of Planets Starfleet ship named after Raman.